Welcome to TechNova Podcast.
Okay, so like imagine you're a scientist and you're trying to, design a new drug, right?
Yeah.
Like a life-saving drug.
Mm-hmm.
And you need to simulate like how all these millions of molecules interact.
Right.
It would take like years for a regular computer to figure that out.
Oh, yeah, absolutely. Centuries, maybe even.
But a quantum computer
A quantum computer.
could do it in like days.
Yeah, potentially even hours.
And that's what we're diving into today. You sent me this article
Yes.
about this new development from Microsoft.
Mm-hmm.
It's this new quantum computer chip they've made.
Right.
It's called Majorana 1.
Majorana 1, that's right.
And they're saying it could be like the key to unlocking really powerful quantum computers.
Yeah, they're making some big claims. They're talking about building a quantum computer with like 1,000,000 qubits.
1,000,000.
All on a single chip. And just to give you an idea, like the most advanced computers we have now, they only have around 1,000 or so.
Wow. Okay. So that's a huge jump. But I think before we like get ahead of ourselves, let's break it down for our listener a bit. What exactly is a qubit?
So think of it this way, right? You have a regular computer bit. It's like a light switch. It can be on or off.
Okay.
And that's like a 1 or a 0.
Gotcha.
But a qubit, it's more like a dimmer switch. It can be on or off or somewhere in between.
Okay.
So it can hold both a 0 and a 1 at the same time. And that's because of the strange rules of, quantum mechanics.
So it's not just two options. It's like a whole spectrum.
Exactly. Yeah, and that's where the power of quantum computing comes in. Because with these qubits, you can explore so many different solutions at the same time.
So it's just way more efficient.
Much more efficient, yeah, for these really complex calculations.
So more qubits means more computing power.
Right.
But the article also mentions that there's this like big challenge keeping those qubits stable.
Yeah, that's the really big hurdle right now because they are so sensitive to any disturbance.
Oh.
Physicists call this decoherence.
Decoherence.
Yeah, even the tiniest vibration or a change in temperature can cause errors, and then those errors can cascade and like the whole computation becomes unreliable.
So it's like trying to build a house of cards in a windstorm.
Yeah, exactly. That's a good way to put it.
Very delicate. So that's why this new chip from Microsoft is so interesting.
Yeah.
Because they're using this completely different approach.
Right.
It's based on something called a topological qubit.
Yeah.
And it's supposed to be much more stable.
Much more stable in theory.
So what makes these topological qubits so special?
Well, they're based on these really strange things called Majorana quasiparticles.
Okay.
It's kind of hard to explain without like getting too deep into the physics. But imagine tying a knot in a rope.
Yeah.
I know that knot isn't like a separate piece of rope, right? It's just like a configuration of the rope.
Right.
Well, Majoranas are kind of similar. They're not individual particles. They're like a specific pattern of electrons that you see in certain materials.
So how does a knot in a material turn into a qubit?
So it's all about how stable that knot is.
Yeah.
Because those knots, the Majorana quasiparticles, they're really robust. They're not easily disturbed by noise or changes in the environment.
Which is what we need for a good qubit.
Exactly. So Microsoft's betting that these Majorana qubits will be the key to finally building these large-scale, fault-tolerant quantum computers.
Okay, so it all comes back to that stability then.
It does. If they can really control and manipulate those Majorana quasiparticles, then they could overcome these stability issues that has been plaguing the field for so long.
Right. But like you said earlier, there's a lot of skepticism. Not everyone is convinced that Microsoft has actually done what they claim.
Yeah, and that's a good thing. It's good to be skeptical.
Right.
The article does point out that, this research hasn't been fully vetted yet.
Oh, right.
Like it hasn't been published in a peer-reviewed journal.
So we need to see more data.
Yes, definitely. We need more data and analysis before we can say for sure whether they've really cracked the code.
And then there's also the fact that Microsoft kind of stumbled a few years ago.
Oh, right.
The article mentioned they had to retract a paper where they claimed to have created Majorana states.
Yeah, that does add a layer of caution for sure.
Yeah.
I mean, it just shows how difficult this kind of research really is.
Right.
And it shows why we need that independent verification.
So it's like exciting,
Yeah.
but we need to be cautious.
Exactly. I think that's a good way to sum it up. We have this huge potential with this Majorana 1 chip,
Yeah.
but we need to temper our excitement.
With some healthy skepticism.
Exactly.
So what do you think is like the most important thing for our listener to understand about all of this?
Well, I think the key takeaway is that this is a really fascinating development.
Yeah.
But it's very early days still.
Okay.
We might be seeing a big step forward, but we need more research.
Right.
We need more scrutiny before we can say this is a revolution in quantum computing.
Yeah, for sure.
It's definitely exciting, though.
Very exciting.
Lots of potential.
Definitely. So we're in this like exciting but uncertain time.
Yeah.
What are some of the things that scientists are looking for to figure out like if Microsoft's claims are actually true?
So one of the most important things is reproducibility.
Okay.
Like other research groups need to be able to do the same experiments
Mm-hmm.
and get the same results. That's like a fundamental part of science.
So it's kind of like if someone says they have this revolutionary new cake recipe,
Right.
other bakers need to be able to follow it and pick the same cake.
Exactly.
Be sure it's actually good.
Yeah. And in this case, the recipe is like creating and controlling these Majorana quasiparticles,
Right.
which is a really delicate and complicated process.
For sure. And the article did mention that there might be other explanations for what Microsoft saw. Like, what are those?
Yeah.
And how do scientists figure out which one is right?
Yeah, that's one of the biggest challenges in this kind of research.
Yeah.
Because there are other things that can happen
Mm-hmm.
that look a lot like Majorana quasiparticles.
Oh, really?
So they have to come up with these really clever experiments
Right.
to rule out those other possibilities. It's like being a detective,
Oh, I like that.
trying to find the real culprit,
Yeah.
and you have to get rid of all the other suspects.
Eliminate them one by one.
Exactly. And that's where that healthy skepticism is so important. Scientists have to be really critical of their own work
Mm-hmm.
and be open to the possibility that they might be wrong.
Right. So even if it turns out that Microsoft didn't actually create Majorana quasiparticles,
Yeah.
could this research still be valuable?
Oh, absolutely. Even if they don't end up building this million qubit computer,
Right.
you know, anytime you do research like this, you learn new things,
Mhm.
you gain new insights, and that could lead to other breakthroughs.
So like when you explore a new continent, you might not find the city of gold, but you could find other cool stuff along the way.
Exactly. Yeah, science is all about those unexpected discoveries.
So it's not always a straight line to the result.
Definitely not, no.
Okay, well, let's talk about like what could happen if we do have these large-scale quantum computers.
Okay.
Like what areas would be impacted the most?
Oh, there are so many possibilities.
Yeah.
I think one of the biggest is drug discovery,
Okay.
like we talked about before.
Yeah.
If you can simulate the behavior of molecules really precisely, then you can design much better drugs.
Okay.
You know, therapies that are tailored to each individual person.
It's like having a virtual laboratory.
Yeah, basically. You can test millions of different combinations
Right.
without having to actually make them in a lab.
That's incredible.
Yeah.
What about other areas? Like what else could be impacted?
So material science is another one.
Mm.
Because with a quantum computer,
Yeah.
you could design materials with specific properties.
Okay.
Like imagine a material that's super strong,
Mm-hmm.
but also really lightweight. Wow.
And you could use that for all sorts of things like
Yeah.
aerospace or energy production.
Wow. So it could be used for so many things.
Yeah, the possibilities are really endless.
Do you think it could change how we understand the universe?
It's possible. I mean, quantum mechanics is already changing how we see reality.
Yeah.
And a quantum computer would allow us to study it even more deeply.
So we could unlock these secrets.
Yeah, maybe we could discover new laws of physics, learn more about space and time.
It's a whole new world.
It really is.
But like with great power comes great responsibility.
That's true.
What are some of the ethical things we need to think about with this new technology?
So one big one is encryption,
Okay.
because a quantum computer could potentially break the codes we use
Oh, no.
to protect our online information,
Yeah.
like bank transactions or communications.
So it's like having a master key that can unlock anything.
Yeah, basically. So we need to figure out new ways to protect our information.
Right? New encryption methods.
Exactly. That are resistant to quantum attacks,
Mhm.
like a quantum arms race.
Yeah, kind of. We need to stay ahead of the game. And then there's also the issue of bias.
Okay.
Because quantum computers can process so much data.
Mm-hmm.
But if that data is biased, then the results will be biased too.
Oh, right. So it could make existing problems worse.
Exactly. So we have to be really careful about that. We need to make sure that quantum computing is used for good.
Right. And that it benefits everyone.
Exactly. Not just a select few.
So it's not just about the technology itself.
Yeah.
It's about how we use it.
Right. It's about our values and our goals for the future.
Yeah, it's something for all of us to think about.
Definitely. As we get closer to this quantum future, we need to have these conversations about responsible development and equitable access.
And make sure it's used for the right reasons.
Exactly.
It's really amazing to think about, like, all the potential here.
Oh, yeah, absolutely.
It's not just about the technology itself, right? It's about, like, what it means for us as humans.
Yeah, it really makes you think about the big questions.
Yeah, like what is reality?
Yeah.
What are the limits of what we can compute?
Exactly. And then there are these ethical questions, too, about how much power we're gaining.
Right. We've talked about all these incredible possibilities in medicine and material science and even our understanding of the universe.
Yeah, but we also have to be aware of the risks, like you said.
Right, like the need for better encryption
Yeah.
and making sure that these algorithms aren't biased.
Right, exactly. We have a lot to figure out.
Yeah. So as we wrap up this deep dive,
Okay.
I want to bring it back to our listener.
Yeah.
Like, what's the main thing you want them to take away from all this?
I think the biggest thing is that we're at this really crucial point.
Okay.
Quantum computing isn't just science fiction anymore.
Right.
It's becoming real.
Yeah.
And it's going to change our world in ways we can't even imagine.
It's like back in the early days of the internet,
Yeah.
or when personal computers first came out.
Exactly. And nobody knew how much those things would change our lives.
Right. And now we can't live without them.
Yeah. And quantum computing could be even bigger.
Yeah. So we all need to be part of this conversation.
Yeah, absolutely. We need to think about the implications and make sure it's used for good.
So it's both exciting
Yeah.
and a little bit scary.
It is. It's a future full of potential,
Yeah.
but also a lot of uncertainty.
But that's what makes it so interesting. Right?
Oh, definitely. I mean, the fact that we get to be a part of this,
Yeah.
it's incredible. We're not just watching from the sidelines.
Right. We're all shaping this future together.
Yeah, through our curiosity,
Hmm.
our ingenuity, and our commitment to doing things the right way.
And that's what's so exciting about it.
Yeah.
So keep asking questions.
Yeah.
Keep learning.
Keep exploring.
Because the quantum revolution is just getting started.
And we're all on this journey together.
Thanks for taking this deep dive with us.
Yeah, thanks for having me.
And until next time, keep diving deep.